jump into today's presenters. We'll start with Dr. Sean Barbeau. Sean is actually joined the research faculty of Qatar in 2004. He served as the principal investigator for multiple research projects investigating intelligent software systems for mobile phones. He has over 40 peer-reviewed papers and conference presentations, and his research interests include intelligent location-based services, lightweight data communication frameworks for mobile devices, and supporting online communities for user-generated spatial data such as OpenStreetMap.org. He has also patented 7 inventions, and another 8 patents are pending in the area of location-aware technology. He holds his MS and BS in computer science from USF, as well as a PhD in computer science and engineering from USF. Our second presenter will be Richard Pascoe, who has been providing GIS services to local government in the Tampa Bay area for the past 10 years. And since 2008, Richard has assisted the Florida Department of Transportation's District 7 with growing their enterprise GIS system and is currently working with them to integrate transit projects and information. Our final speaker is Elba Lopez, who is the Transit and Intermodal Administrator for the Florida Department of Transportation District 7. Over the past 10 years, Elba has managed and overseen varied multi-million federal and state federally funded projects that include the direct oversight of the Tampa Hart streetcar safety security requirements and implementation, the first regional transit infrastructure handbook, and oversight of the project funds associated with the establishment of the Tampa Bay Regional Transportation Authority, Most recently, Elba has worked with Qatar as the project grant manager on the Regional Public Transportation GIS Architecture and Data Model project that was the subject of today's presentation, which is an interactive transit intermodal systems planning tool that promotes strategic opportunities and system decision-making when considering funding and placement of transportation options within Florida DOT District 7 in the Tampa Bay area. For those who are not familiar. With that, I'll turn it over to Sean, I believe.
Thanks, Phil. So today we're going to be talking about a project that we did here at Qatar, and it was funded by the National Center for Transit Research and the Florida Department of Transportation. And this involved automating the data exchange of public transportation information between the different agencies in the greater Tampa Bay area. So to give you an overview of the presentation today, we're going to talk a little bit first about the challenges in regional transportation coordination, and Elba and Richard are going to give us some background of the project and resulted in the genesis of this particular project. I'm going to talk then a little bit about the Regional GIS Architecture and Data Model project, background to some of the software that we developed, and show a brief demo of the system via some screenshots. And then finally, we're going to talk about the next steps for this particular project. So with that, I'm going to turn it over to Elba Lopez from FDOT District 7, who's going to talk about some of the background of this project.
Thank you, Sean. You know, as I was thinking about this, I thought about what Disney had stated. He said that the most important part of a project is coordinating with those who are working with you and aiming their efforts at a certain goal. But from past experience, I'd add that the goal has to be clearly defined so your project doesn't capsize midway there. A number of years ago, we actually tried to come up with a systematic method of capturing transportation data for critical regional planning, interagency project coordination, and possible funding opportunities. But in the process, we quickly found out that coordinating efforts in transportation can be very tricky if that method isn't clearly defined and understood by everyone. Needless to say, the project did not generate the end product that we were expecting. And as some of you may know, D7 is composed of 5 counties. That being the case, you can imagine the number of agency jurisdictions and points of contact that we had to interact with. And they seemed to constantly change in the process. Most of them were handling varying job responsibilities. Even worse was trying to determine everyone's technical expertise with data management and methods used for data storage, and then how to actually exchange and format and analyze the data. But we didn't give up and actually had the opportunity to explore other avenues with our district GIS analyst, who was Richard Pascal at the time, was working with the department, and he was able to assist us in formulating potential resolution. So Richard, with that, maybe you can discuss that a little bit.
Thanks, Elba. During the many years that I was on site at the Department of Transportation, District 7, there was always a place for transit information in the enterprise GIS database there for bus routes and bus stops. And for many of those years, we used data from the Florida Geographic Data Library to populate that information. But it was really a problem because FGDL rarely updated any of the information. In fact, I think at one point in 2010, when we started thinking up the idea for this project, the data hadn't been updated since 2008, so we were dealing with really old information. And so what we had to do often was resort to calling the 4, I think now 5, transit agencies that are within District 7, them being the Pinellas Suncoast Transit Authority, Hillsborough Regional Transit, Pasco County Public Transportation, Hernando, and Citrus both have public transportation systems. And we had to call all of them to get all of their transit information 4 times a year, because that's how often they updated their data. And when we contacted them, all of their data would be in different formats because they were all exported from various scheduling software, such as like Trapeze or Hastus. So needless to say, it took many hours to import all of that data, massage it, and get it all into a common schema. It just took a lot of effort, and at the end of the day, we just realized that if D7 FDOT District 7 was going to keep current transit information, they definitely needed a better, more automated solution. And with that, I'll hand it back over to you, Sean.
Thanks, Richard. So that gives you kind of a background of some of the challenges that led to the creation of this particular project. So the goal of this project was to tackle 2 of the biggest challenges that we saw, which was one, as Richard just said, creating a common data format for all the transit agencies in the region. So this involves talking with the stakeholders that are involved, FDOT and the transit agencies, and coming to an understanding of what different formats each agency can provide, and then consolidating that into one particular format, which is our data model for this particular project. Then the second aspect that we're trying to achieve with this project is creating software to automatically retrieve transit data from the regional agencies and import it into the FDOT District 7 geodatabase. So this is the GIS architecture component of the project that involves taking the data that each individual agency produces and developing an automated method to retrieve that data and reduce the effort required for manipulating that data into a single format and then importing it into the FDOT database. And a second benefit of the project is also developing a common web-based view of this data for all agencies. So this allows all the agencies involved to see an up-to-date view of the data without having to go through the process of contacting someone at the agency and retrieving the data set manually and going through the data manipulation process. So the first aspect that we had to tackle of this project was what exactly is this common data model going to look like? So what really made the most sense is to try to leverage something that's close to what the existing transit agencies in the district and around the nation, because we really want this project to be applicable to anywhere, not just to Florida. And so we were looking at the different formats that were out there, and we identified the General Transit Feed Specification Format, or GTFS, as really the most promising format to facilitate the exchange of data between the district and the various transit agencies. So as you can see on this slide, GTFS consists of multiple text files that are in one zip file, and each of these text files contains certain comma-separated fields and information. So, for example, what we see here is the stops.txt file that contains information for bus stops. And inside that file, we see things like a stop ID, a stop name, and then a latitude and longitude for that particular stop. So GTFS came out of some early collaboration between TriMet in Portland, Oregon, and Google at the time, who wanted to add public transportation directions to their online trip planner. This online trip planner became Google Transit, which has become extremely popular, and there are a large number of agencies around the world that are putting their data into GTFS format. Many of these agencies put their data into GTFS initially to participate in Google Transit, but there are a large number of other applications out there that also use this exact same format. And some other examples are the open source projects Open Trip Planner and One Bus Away, which is an open trip planner is an open source project for trip planning that's based on GTFS data, and One Bus Away is a real-time estimated arrival open source software system that uses real-time data in addition to GTFS data. So when we were looking at the status of the GTFS format in the state of Florida, we were pleased to see that there were actually a large number of agencies that were already maintaining, both creating and maintaining their data in the GTFS format. And the maintenance portion of that is very important, because in order to have data up to date, each agency not only has to create the initial data set in GTFS, but also maintain that. And each of these agencies that you see on the slide, from HART, PSTA, SCAT, LETRAN, the other SCAT we have in Florida, Broward County Transportation, Miami-Dade, Links in Orlando, RTS in Gainesville, Citrus Connection in Lakeland, and Tri-Rail in Pompano Beach. Each of these agencies is already maintaining a GTFS data set to participate in Google Transit. And for agencies that don't have their data in GTFS format, the rough estimated cost for taking their data and working with a consultant to maintain or to create a GTFS data feed is roughly $200 to $500 per route, depending on the complexity of the system. And many of the existing software packages out there actually do support exporting to GTFS format. So for agencies that want to manage this process in-house, different software packages such as Trapeze or Hastus today also support exporting to the GTFS format. There are also a number of other open source tools out there that agencies can help use to develop a GTFS format for their agency. So we looked at the GTFS data format, and in collaboration with FDOT District 7 and the various transit agencies in the area, we identified some additional fields that weren't specified in the GTFS format, but would be useful both to the transit agencies and to FDOT District 7 to have in this common data set, that both of the all the organizations involved could see this information, as well as the core GTFS data. So some additional properties that we identified as being important were whether or not a bus stop had certain amenities, which I'll show here in a second. Also identifying further route classifications, so identifying whether a particular bus route is a local route versus an express route. Other performance statistics, so for example, boarding and alightings per stop. were also useful to both the agencies and District 7. So we identified a way that the agencies could add this data to their existing GTFS formats. So what we see here at the bottom of this slide is a sample row of data in the GTFS stops.txt file. So here we have stop ID. This example is 1645. So this is an identifier field that's already in the GTFS format. But each of these additional fields that you see here, from bike racks on the left-hand side, the presence of bike racks, to boardings and lightings on the right here, all of these fields are additional that an agency would add to their GTFS feed to participate in exchanging data with FDOT District 7. So a 0 or a 1 here, 0 means that a bike rack is not present, for example. A 1 indicates that a bike rack is present at this particular stop. When we were working with the agencies to design this system, it was important for us to be able to identify a process that was really added as little manual effort as possible for the agencies. We understand that the agencies already have a lot to do, often with constrained budgets and time. So we worked with the agencies to look at the different options for adding this data, and really the easiest option we saw was an agency can just can generate their GTFS file like normal, and then open up their stops.txt file and into a spreadsheet program like Microsoft Excel, and then sort their data by bus stop ID, and then go to their existing data set that has this extra information about bike racks, signs, park and rides, etc., and just literally sort that data by stop ID as well, and literally do a copy and paste into the GTFS stops.txt file. So then saving that information back into the original stops.txt file. So working with HART, for example, they had their data readily available, so their process for doing this was under a half hour for the first time, so that includes the learning curve along with it. So we believe that the process that we came up with is really about as efficient as we can get for leveraging the existing GTFS data set that they have, and then adding a few extra fields that are valuable to both the agencies and FDOT District 7 to see in this shared view of the regional data. So this is a system architecture diagram showing the regional GIS architecture that was created as part of this project. So on the left-hand side here, we have the existing transit agency web servers. So for example, the HART server and the PSTA server. And these servers contain the GTFS data for each of these agencies. So the normal project, or our normal process for a Google Transit update is for Google software to fetch the GTFS file off the agency server, retrieve it, and then process it internally to turn it into the Google Transit trip planner. So we follow a very similar process. The first piece of software that we developed for this application is what we call the GTFS Data Sync, and it's a desktop application. So this runs on any desktop computer. And what this application does is requests the GTFS data for each participating agency. So it will send a request independently to each agency's web server that's participating. And then we'll retrieve the GTFS file automatically from each web server. It processes that data internally to turn it into a format that's compatible with the FDOT District 7 spatial database, their enterprise database, geodatabase. And then it inserts that agency data automatically into the FDOT District 7 geodatabase. So this is literally a one-click process from starting the application, retrieving the transit data from each of the agency's server, and inserting it into the FDOT District 7 database. And that process replaces the manual process that Richard was talking about, where they would have to independently contact each agency via email. Each agency would have to grab the most recent data and then send it manually to Richard and some of the other staff at District 7, and then they would be responsible for converting that to a format that worked with their spatial database. So this is really a huge time saver to be able to automate this process. And the second application that we developed for this particular project, we see here in the upper right-hand corner, which is the regional data visualization web application. So this is a web server that can, just like a normal website, that can be accessed by anyone with an internet browser. So here we have all the different users that can log into the web server and see the data that's stored in the FDOT District 7 geodatabase. And this replaces some of the proprietary software tools, such as our GIS desktop products that would previously been required for an individual to see the data that was in the geodatabase. And that also, those tools require specific skill sets to be able to look at the data. So we're really just facilitating the process of any user, not necessarily someone with GIS expertise, being able to look at a snapshot of the most recent up-to-date data for the entire region in one particular interface that's accessible via any desktop computer. So looking a little closer at the first software application I mentioned, the desktop application, which retrieves the GTFS data from each agency and stores it in the database. As I mentioned before, estimated 30 minutes to 3 hours work, including the initial learning curve. This is based on several agencies' feedback that we worked with. So the process is the transit agency adds the extra fields to their GTFS data that we talked about earlier, the bike racks and boardings and the other fields. And then they upload their Google Transit.zip file to their agency website, just as if they would do in their normal process to make the data available to Google Transit. And then FDOT District 7 runs the GTFS Status Inc. desktop software. And here you see an example output of that software. It shows that it's downloading the GTFS file from what would be one of Hart's servers here, Hart's GTFS, and then automatically goes about inserting that into the FDOT District 7 geodatabase. So then the second piece of software that we developed for this project is the regional visualization website. And again, this is where anyone in the region can go to see the snapshot of the most up-to-date bus route and bus stop data for the entire region, which can include multiple transit agencies. And in the same interface, which I'll show shortly, we can also view FDOT's work program data. So this allows not only the district to see the transit agency's data, but also allows the transit agencies to see FDOT's data. So the work program data would be things like planned construction programs for roads and other projects which could potentially affect a bus route that's running on a particular road or a particular bus stop if there's construction in the area. So this allows the agencies to be able to see the most up-to-date data and be able to coordinate much more easily than they would if they had to manually exchange data sets and use specialized tools to be able to view the data. So what we see here is a snapshot of the initial agencies that participated in the pilot project that we had data from. So this is both Tampa and Hillsborough County, which is covered by Hillsborough Area Regional Transit, and the Pinellas County area, which is covered by PSTA. And as you can see, there is connectivity between the two transit agencies as well. This involves coordination between the two transit agencies as well as the FDOT district that covers that same region. So we also see here some of the traditional tools you would expect from a map interface, being able to zoom in and out and be able to turn on and turn off different layers such as Hart bus stops and routes, and as well as the FDOT data. So if we zoom in a little closer, we'll start to see data that gets a little more interesting. So here we're able to see the purple lines represent the Hart bus routes, which are running in Hillsborough County. We also see the circular representation of the different bus stops that are located along the Hart routes. So the number that you see in and the circle here represents how many individual bus stops are in that immediate area. And by representing multiple bus stops at this zoom level by one marker, we're able to scale the system much more easily, so we can show the entire region. If we tried to load each individual bus stop to start with before you zoomed in, the web application really slows down. So this enables the application to be very efficient. And then we can zoom in further if we want to drill down to the individual bus stop layer. What we also see here in blue is the FDOT work program data. So this shows that the FDOT has a project which is happening on this particular road, which would cross over three different HART routes here, and an additional example down here closer to the interstate. And again, you see the HART data from this view, as well as the FDOT work program data. So if you drill down a little further, as I mentioned, you're able to see the multiple different bus stops that are in a particular area. And if you click on one of those stops, you get a little more information about that bus stop. So some items here, such as bus stop ID, which is a unique identifier we saw earlier in the GTFS data, and some information about that stop. So it belongs to the HART agency, name for that particular stop, and then the extra attributes that we saw here earlier. So for example, there is a sign at this particular bus stop, there is a shelter, and there is a trash can. There's no restroom that's immediately there that's maintained by HART. And you see some other statistics such as boardings and alightings in average per day. I believe this is this statistic. And if you click on the routes that you see on the map, you get some similar information, what route what agency the bus route belongs to, some description information about the route ID, a long name for that, as well as some subtype identifiers, which can be used to tell whether the bus route is an express route or a local route. And again, if you drill down and look at the FDOT District 7 work program data, so this is the blue line that we saw earlier, and you click on it, you get some information that's specific to that particular work program in the FDOT District 7 geodatabase. When this software goes to production, there would be additional fields here. This data is meaningful to FDOT internally, and we wanted to show this as a proof of concept for the project. But this would include extra text descriptions to make this a little more user-friendly to the transit agencies that are looking at this data, so they can make sense of this as well and understand how these programs will interact with bus stops or routes that they may have in the area. So we also see a toolbar at the top of the window here that you can use to query the data and filter it more specifically if you're looking for shapes, bus stops, routes, or work program data that have more specific attributes. So the example that we see here is the user is selected to search for bus stops that have a bus shelter associated with them. So the shelter value is greater than 0, so it's 1 or higher. So some of the challenges, to talk about some of the challenges that we had as part of this project. So ultimately, I think we were able to resolve the various challenges that we saw as part of this research project, and was able to produce a system. So some things to just to recognize some of these challenges that we worked through. So again, as Richard and Elba mentioned earlier, there really are varying skill levels of data analysts at each individual transit agency. And this is largely dependent on the size of the agency and how many personnel they have in-house that are dedicated to deal with things like data and specifically GIS data. And this really ranged from highly skilled, some agencies that we dealt with had individuals that actually did have GIS training, and their position was a GIS analyst in the agency. We dealt with some other agencies where the The data analysis was really a secondary duty. It was really tacked on to someone whose main job duty was to manage the schedules for the public transportation. So not quite the skill level of someone with a GIS training and background. And then lastly, for some of the smaller agencies that don't have in-house data analysts or someone who can tackle some of these tasks, and for those particular agencies, the data analysis is outsourced. So we ended up dealing with some organizations that were outside of the immediate transit agency staff to work towards this particular project. So in our pilot project, HART and PSTA were able to provide the full data sets that we developed, the specifications that which we developed as part of this project. So that involved both the GTFS data plus the extra data that we defined as being useful based on District 7 and the transit agency feedback. So at the time, Pasco County Public Transportation was the other agency that was participating in this pilot. They didn't yet have a bus stop inventory that was geocoded or a GTFS data set. So I know that's something that they're working towards in the immediate future, but as of the wrap-up of this project, they didn't have that particular data in place. Another challenge is determining when exactly to collect the data. So when we were working with Pasco County Public Transportation, they were in the middle of going through some route reorganization, which involved moving some bus stops as well. And so to some extent, you don't want to commit resources to collecting data if that data is going to change immediately on a large scale. On the other hand, transit agencies are usually going through some changes to adapt to other construction projects or changes in routes based on ridership. So really balancing when do you exactly collect data is something that the agencies need to consider. And from our perspective, though, looking at the various stakeholders in the region, really some data is better than no data. So I think that's something that we learned is that it's better for an agency to share what they have or to share the data that they're going to collect rather than to not share anything at all. And another technical challenge more associated with the GTFS format, the shape information or the exact path that the bus travels as it travels from route to route, that information is not required in the GTFS specification. So Google Transit, for example, uses that to show when they're showing a user a trip plan, that enables the line that they draw for the bus path to match, for example, curves in a route. If that information doesn't exist, then applications such as Google Transit and our particular application, the web application here, you're really just doing a connect the dots of the bus stops, because we know the order of which the bus will visit bus stops. So we can just draw a line from one bus stop to another, but that may not necessarily represent the path of the bus on the actual road if it curves back and forth. It would just be a straight line instead of a curved line. So for our application and for others, we believe that including the shape information is important. It really gives you a much better idea of exactly where the bus is traveling rather than not including the data. So this software that we developed as part of this project, we made it open source on GitHub, which you see the link to the project down at the bottom of this slide, because we really want to make this available so that other districts in Florida can adopt this same system, as well as agencies around the United States and across the world. Working with enterprise geodatabases is something that can be challenging, working with Esri software, and there's not a whole lot of open source examples out there. So we really hope that this serves as examples to others. I'm now going to turn it over to Richard, who's going to talk a little more about the future of the software that we developed under this project as he works with District 7.
Thank you, Sean. Currently, the tools and the database objects and everything that was developed in this project are essentially deployed at District 7. They're ready to consume and load data into the District 7 Enterprise database. on a quarterly basis as the information is uploaded from the various transit agencies. However, coordination with the various agencies, of course, has been challenging. As Sean said, only 2 agencies are currently on GTFS, and understandably, they have been apprehensive to directly edit their GTFS files and add the additional data. They've actually added it to another file, separate one that District 7 has been having to download, which doesn't really cause too much of a problem, but it'd be preferable to be in the original file. And at the same time, it hasn't really been kept up to date. They haven't updated it in a while. So we're still working on coordinating with them to get that updated on a consistent basis. You know, they've had, I know at least 1 or 2 of them have had some problems just with resources and people who are able to actually create the information for District 7. Of the other agencies who are not on GTFS, it's just going to take time for them to be able to get on that. And also FDOT, I know, has offered some level of assistance to be able to assist any of those agencies to get on GTFS when they're ready to do it. FDOT District 7 is also investigating how to share this website publicly from the Department of Transportation. They now can share a web application publicly. They just have a little bit of work to do on it and just some research and to figure out how to do it. But they can do it through a new statewide GIS framework that the Florida Department of Transportation has recently implemented within the past year. And that, I think, is really what's going to be truly important, is the Department of Transportation to be able to share that back out with other agencies and the public, you know, to be able to coordinate projects and see where there will be any potential issues without the transit agencies having to try and get into the FDOT network through VPN, and there's various, you know, technical issues that can arise with that. It'd be a lot easier if they could just open up and go to the internet and see it. So at the same time, it's also kind of a carrot and the stick situation. If, you know, the agencies and, you know, metropolitan planning organizations and county government can get on there to see the information, to be able to use it, it's going to be incentive for them to, you know, to get on board and start uploading their data. So here's all our contact information if you'd like to write it down. And with that, I think I'll hand it back to Phil to be able to handle any of your questions.
All right. Thank you all. And what we'll do is a reminder to 2 reminders. One is you can submit your questions through the Q&A in the upper left-hand corner, like Jennifer mentioned in the beginning, or for those that may not have been there, just click this one, type in your question, and then click where it says Ask, and that'll submit them. And as another reminder, you can also download a copy of today's presentation. If you look in the upper right-hand corner of your screen, you should see what looks like 3 sheets of paper. Click on that, and you can click on the kind of webcast presentation for today and download a PDF copy of today's slides. So thanks to Sean, Richard, and Elba. And I have a couple questions for you all while others are typing in theirs, I'm sure. You mentioned that the agencies, you all use the GTFS type of data, the Google Transit stuff. Do they need to be on Google Transit to be able to put it in GTFS format?
That's a good question, Phil. The answer is no. The agency doesn't necessarily have to participate in Google Transit to share their GTFS data. Google Transit is really just one application that consumes GTFS data. But if an agency chooses not to participate in Google Transit, they don't have to. We do see that, though, as a potential benefit to the agency, and the reason why many agencies have gotten their data into GTFS format is that they do get a free online trip planner out of Google Transit. But there's no hard and fast rule. The agency can share their GTFS data how they want and participate in any applications that consume GTFS data based on their preferences.
All right. Thanks, Sean. In the issue of those additional items you all added to the GTFS data, I mean, how did you come up with that list? Did you do it with the transit agencies, or?
Yes, we worked with, we had a working group as part of this project that was coordinated, excuse me, by FDOT District 7, and Elba and Richard were both involved in that process. So early on, we identified some of the people that would have ownership over creating the data that would be added to the GTFS data sets at the participating agencies. So HART, PSTA, and PCPT all participated in that regional working group, as well as participation from some of the MPOs and the cities as well had some of their personnel attend those meetings. So there's really consensus that those particular extra fields would be useful for operational purposes. GTFS was really originally designed to power trip planners, so excuse me, some of the things like boarding and the lighting statistics really weren't relevant to some of the early users of GTFS. But in the communication that we had with the working group and the participation by the various agencies, we identified that as being something that is useful. And going forward, it really, if there's other fields that are identified as being useful, or other agencies and other states want to take the same software, they can choose to add different fields that are valuable for them as well.
Okay, thanks, John. Actually, kind of picking up with that, one of the other questions that just came in is, what was the source of the boardings and the lightings values?
I don't know if Richard or Elbo wants to take that and answer it more specifically. I believe it's based off of the automated passenger counter systems that the transit agencies have. I don't know if Richard or Elbo, you can shed more light on that.
Sean, I believe that at least for the ones that are in GTFS, PSTA, and HART, I believe they are using APCs to collect that information. And the boardings and alightings are, I believe in there, if you didn't say before, are the average weekday boardings and alightings. And I think they are collected by APC.
And that is correct, Richard. Yeah.
Okay. All right, thanks. Okay, interesting question has come in. It says, I wonder if you use a universal stop ID system to uniquely identify stops across agency GTFS feeds for your region, or is your lat-long data sufficiently precise to differentiate between two stops from different feeds located close together, you know, from the same stop as represented by different agencies?
Oh, yeah, that's a really good question. For our particular, the early use of this system by PSTA and HART, PSTA and HART each have their own system of numbering stops. So there's a unique identifier for each PSTA stop and a unique identifier for each HART stop. So within our database, each stop can be uniquely ID'd across an agency and across multiple agencies by a combination of the agency ID, which we have in our system, and the bus stop ID. So we really use a combination of those to uniquely identify a stop. There's nothing preventing, I know some other regional agencies that may have to more closely coordinate transfers and that type of thing, do use more of a universal unique ID. So, for example, I'm sorry, they may coordinate with another agency to share a stop ID. So that's more of a universal stop ID concept where stop ID 300 for HART would be the exact same bus stop as bus stop ID 300 for PSTA. So I know the way that some other applications handle whether or not that a particular stop that doesn't have a universal ID numbering system, whether or not those are the true same bus stop on the ground, is to look at the proximity of those stops. And when the accuracy of the geocoded bus stops is really good, that system works really well, but it can be challenging if you don't have really good quality geocoded bus stop information, and it's kind of fuzzy whether or not the two bus stops are actually located close enough to one another to be the true a single actual bus stop. So I hope that answers the question. That we're using a combination of transit agency name and ID to uniquely represent a stop, but we could also easily support a universal stop ID system using this software and process.
All right, thank you, Sean. The question came in, did you mention or did the data partners collect bus stop accessibility for each bus stop? The note is that this is an optional GTFS data element, but I'm not clear if this project team decided to manage or use that ADA accessibility data, and if not, do you recall why not?
I'll take a first shot at that question. So a list of all the different fields that appeared, if you go to the link that we presented earlier in the presentation, which is downloadable, the final report is available on that site, which does have a list of all the different fields that were included for the exchange of data between the agency and the district. So I believe that we did not include accessibility looking through the different field types here. And the reason was that we couldn't, the agencies didn't have enough detailed data collected that could really be represented in a simple field. So for the initial pilot portion of this project, we didn't add accessibility data. And for example, some of the different metrics are the size of whether or not there's a concrete pad, the size of the concrete pad, availability for pedestrian infrastructure at the location, and there's different slope requirements. So all those things are really more data the agencies than all of the participating agencies had to share. But again, those if there were fields that wanted to be shared, agencies could definitely add those fields to the system. I don't know if Richard or Alba, you want to talk about that more specifically.
I can add a little more, Sean. Back when I was working with HART on their bus stop data collection for infrastructure and ADA, their database had 80 fields. I think 50% of them were ADA related. And there's just so much information that you can collect from ADA, as you started to say, you know, like size of a bus stop pad, width of sidewalk, slope of a curb cut. I mean, the list goes on and on. I think that getting into that information became a little bit out of the scope of this project and what we were intending to do. So it seemed to me like we kind of just agreed to deal with infrastructure, and not only just infrastructure, but infrastructure that was very common between most agencies that you would typically see at a bus stop. You know, so if there's a shelter, maybe a bench or a trash can, so on and so forth. Really just, you know, to add a little bit more information that's necessary to do kind of operations analysis, but not get too far outside of the scope to start getting into all these details that many of the transit agencies that we were dealing with, I think only 2 out of the 5 had ADA information.
Right. And I would just add that, you know, we do understand that it is a critical item, but given the fact that Sean expressed before, you know, that this was a pilot project, we wanted to basically get at the infrastructure first, and ultimately we hope to expand this to include that critical element.
All right, thanks. Next question is, how does the addition of those fields affect the compatibility with the GTFS data exchange or the ability to submit, those transit agencies to submit to Google Transit? Do they need would 2 completely separate files need to be made, or, you know, one for the district and then another one for the Google Trip Planner?
Both a single GTFS file can be used for both Google Transit as well as other applications that consume GTFS and this particular project of exchanging data with the district. GTFS does have, in the specification, there are reserved field names such as stop ID, stop name, stop latitude, stop longitude. Any of that data that appears in the GTFS data set, we're just using the existing GTFS field names. And we made sure that any additional data that we added didn't interfere with any of those official GTFS specification fields names. By the GTFS spec, applications should ignore any fields that they don't understand. So they will expect certain fields, such as a stop ID or a route ID, to be present in the GTFS data file, and they'll consume those fields. But any other field, for example, the trash can field that we added, if an application doesn't understand that and it doesn't appear in the GTFS spec, the application should just ignore it. So I think in practice, I know a few of the agencies that we mentioned were kind of nervous to combine that and didn't want to potentially break something that was already working. So I think that's something that the agencies just have to get comfortable with and be willing to combine them. But yeah, in terms of the compatibility, it should be a single GTFS file should be able to be consumed by Google Transit and by the district that has these extra fields.
Okay. In terms of the issue of, I guess, the complexity of doing this before this type of system existed, is there a sense of how much those will either improve efficiency or reduce costs for the department? Richard or Elba?
Well, for us, it involves looking at, like Richard Pasco had stated before, looking at our work program and being able to try and determine, even from beforehand, where it is that we can coordinate with, let's say, the transit agency to do some improvements, bus bays, that type of thing, as we're doing construction on a roadway. So there's where you're looking at some potential cost savings to both the transit agency and to help out with the roadway construction and smooth out areas where we know that we can do a lot of improvements.
Right, Elba. I mean, that's I think a good example of the typical cost savings that you could have having this in place would be that a transit agency would be able to see far out ahead that FDOT was going to, let's say, widen a state road, and so the transit agency would know a good 5 years ahead of time, or maybe even more, that FDOT was pretty much going to have to tear up everything in the right-of-way and widen the road, so the agency would be able to start planning well ahead of time, knowing exactly what bus stops and how much infrastructure and everything was actually going to be affected, and kind of start putting that into their work program as well.
Okay. I guess one final question is basically knowing what you know now, and if you were starting over, is there anything you do differently, or anything that either surprised you positively or surprised you with, like, oh my gosh, we hadn't thought about that? From a transferability, if somebody's in the audience going, hey, we'd like to do this too, what advice would you give them?
So from my perspective, I would say the one thing that communication with the people that are managing the data is just really important. And we had some handoff with one of the agencies that we were doing from one personnel to another. And in the process, I think some of the goals of the project got lost in translation, and we had to come back and kind of do a reorientation again of why we were doing this project and why it was important to the transit agency and the district. So I think just understanding the various skill levels that are involved, and working with the agencies too to plan the really baseline requirement for participating in this is a GTFS data set. You wouldn't necessarily need to add the additional fields to have just your normal GTFS data imported into the district database. Of course, you would then lose the extra information. So those particular fields wouldn't be available for everyone to see. But I think just communication between everyone in the regional stakeholders, and then just monitoring and promoting the development of the GTFS data set for the regional agencies is important.
Okay. Richard or Elma?
I think overall, you know, hindsight is always 20/20, but I really think that it is a good product, and definitely, you know, there's areas for improvement and in the data collection and working with the transit agencies and ensuring that they're uploading the information. But those are coming along fairly well. I know that Pascal right now is in the process of hiring somebody and getting them on board. Once they do, then we go back and we do some training and being able to assist that person and the agency in uploading information. But overall, you know, I'm really quite satisfied that we kind of achieved the goal. Like I stated before when I was introducing my portion, that's the most critical thing, and I think that we achieved that.
Okay, if you don't mind, let me ask one more question. I apologize to the person who submitted this. It was a two-parter, and I only gave the first part before. The second part is there any interest in using this transit data for MPO and DOT travel demand models?
There definitely is, and that is one of the reasons that we'd really like to make this as interactive as possible, because there's a lot of opportunities in our area to be able to interact at that level.
And I'll say, too, from a technical perspective, the nice thing about GTFS is it was actually designed to support trip planning of how do I get from point A to point B using the bus stops, routes, and schedules that are available. And so while the initial deployment of this project focused and the visualization was focused on the routes and the stops, all the other schedule information and the arrival times of each bus at a particular stop is all contained in the default GTFS data. So that means it's very easily, definitely possible, even using tools like Open Trip Planner Analyst or some other open source tools that are out there to see how long it takes to get from point A to point B using the GTFS data. So definitely more sophisticated tools and modeling and routing based on this data is also possible.
Okay. And with that, I'd like to thank everybody. I would note that this particular project was funded under our National Center for Transit Research with support from the Florida Department of Transportation, including with Elba's guidance as project manager for that. And Elba, Richard, and Sean, thank you very much for a very thorough presentation. I think we got all the questions answered that were submitted. For those that are online, would you take a minute, please, and please complete the evaluation? And please feel free to check back to the Qatar website at any time to see what our upcoming schedule in 2013 will be. This is our last Qatar webcast for the calendar year, and with that, I'd like to wish, on behalf of Qatar, we'd like to wish you very happy holidays. So long.